Hi, and welcome to the Notepad Show. In part two of ABCs of AOVs and LPEs, I'm going to be talking about LPEs. But before we do, I usually start by opening up Houdini. Instead, I'm going to start by showing you an animation and then showing you Nuke. So here's an animation I did for this episode, this project. It's a fur ball just going across the screen and a neon light that's turning on. So the neon light is the real star here. And what if I told you that this was not done in a traditional way through the DCC, through, in my case, Houdini, through an EXR sequence? It was done in the EXR sequence, but the EXR sequence, well, it looked like this. So this was the EXR sequence. And then I turned it into this animation here. And I did that through the power of LPEs. So I'm going to stop the timeline here, put the ball right there in the middle. So here we have this neon light, and I can change the neon light to be off, to be on. I can change its color. I can turn on a stage light that's off to the right. I can turn off or really power up the overhead light. I'll turn it off. I'm going to turn the left stage light on. And you're literally changing the scene through LPEs, through these passes that are associated with the light. This is just a standard EXR file that has some passes that are LPE passes that are controlling light, and I'm modifying them, of course, doing a addition merge on them and then bringing them out to the display. And I'm going to show you guys how to do that in Houdini, but I'm going to explain how LPs are structured as best I can, because it is a wacky world when it comes to the structure of LPs, but I'll do my best. So why don't we go over that first, and then we'll hop into Houdini. And I'll show you how to create these passes. Okay? So, first thing to do is, what is an LPE? How's it structured? Again, a light path expression. Path being operative word here. That is for a forward path tracing transport. There are bidirectional path tracers. Of course, RenderMan has one as well, PXR Unified, but LPs are not supported in the other direction. They are only supported in the forward path tracing mode, and that is rays come out of the camera, which is C. They hit an event. And I'm going to bring up a graphic here. The camera hits an event, and then light bounces. And in this case, this LP will record just one bounce to a light. So we have a camera, a diffuse hit, and then right to the light. Here, on this LPE, I'm doing a direct diffuse. And that is, from the camera, I'm doing a single event. I'm recording, and there are two types of scatter types that you can have. I'm recording a reflected one, and I'm also recording the diffuse. And when I say record, I'm creating a pass that gets written to a display channel. Then I have big brackets, these big red square brackets, and they say anything in here, either or, do. So also record all light paths. That's the event. All light paths. The dot is a wildcard, and also any emissive objects. And generally that's glow or a mesh light or a light that has the camera visibility turned on. Okay. Now, besides a reflective light, this could be set to T. And if this hit were, let's say, a subsurface scatter shader and subsurface scatter surface, then it would record transmissive diffuse light. If it were a piece of glass, it would be a transmissive light with specularity, because glass is fully specular. So, well, with all that said, I'm going to show you a couple other examples. Here is LPE, it's camera, with a specular hit and right to the light. So that will be what is recorded. So you will see a recording of both indirect and direct specular. And it will be also recording the one hit to the light. Then you can get more complicated, and you can have an LPE where the camera is recording a diffuse hit. Then it records a second event where it goes through a specular transmissive object, bounces around a little bit, and then eventually hits an emissive object, a mesh light. Okay? So that is how LPEs are structured. There are other, and these are called tokens. There are other tokens that are out there that can control bounces. You can have a asterisk or a plus. And I'm going to suggest, and I'll put this in the description, that you go to Pixar's website and read up on LPEs and light path expressions. They have a really, really detailed look at all the different expressions that you can write and all the different types of tokens and the different scenarios in which you would use them. I say this because it can get incredibly granular on what kind of things you can record with a LPE. They can get really defined. So it's strongly suggested that you go and read up on this on RenderMan's website. 99% of the LPs that you're ever going to use are already built into RenderMan, and I'll point them out right here. So here are some of the basic lighting AOVs that you would run into: indirect, direct, diffuse specular, indirect specular, subsurface. And they can get really, really, here you have user. So you can have scatter events. So I can do a reflection on a specific lobe. That's what they're called, a user lobe. A lot to take in. You'll definitely should read this website. I will also preface that LPs are case sensitive. They're generally, how they're written here with capitals is how you have to write them. I don't think I've had issues with using lowercase. Okay. All right. So now, finally, let's go into Houdini and take a look around at how they're made. So like in the last episode, we go to the ROP, we go to the image tab, and we go to extra image planes, and we have this custom area. We also have this lighting area. These AOVs are the LPEs, are all LPs. So these are the AOVs that are made up of LPs. They're the lighting LPs, light path expressions. So there's a long LPE here, no throughput, no infinite check, no clamp, no unoccluded, an overwrite, and then here's the camera that whole thing is what an albedo passes. Now, you don't have to remember all that. You just check off the box. But if you highlight, you get an idea of all these different LPEs. Okay? And again, 99%, these are the 99%, are all you'll ever need. I'm about to show you the 1% where you can control, well, it's not 1%, but where you can control lighting. It's figure of speech here. But let's do this. So I'm going to go to the right light here. Make this a little bit bigger. Okay. This is the LPE for recording everything about the right light. Now this right light is right here. So whatever this does, I want to record that as a pass. So when we look at this, we have a camera. We have a single event where we are recording, and this is the and or, anything inside the brackets. We are going to record a reflected hit, or a transmissive hit. We're going to record a diffuse bounce or specular bounce. This is an asterisk. This is a token for repetition. So however many times this happens, record it, and also record any light that has this name plus any emissive. This string, which is a custom string, and I'll show you where that's created now, that is created at the light level under the Advanced tab, right here under Light Group. And again, it's so useful, the RenderMan Houdini help system, where if you highlight your mouse over a parameter, it will show you some helpful hint on what that parameter is. In this case, we're specifying the light group to be used in an LPE, useful for generating per light AOVs for later adjustment and compositing. So we created, and this string can be whatever you want it to be, right underscore LGT, and then I went into the AOV, custom AOVs. Now here I created a custom AOV name, and then this is the formula. And these LPs I'm going to put into the description so you will have them forever. You can always reference back and can copy and paste. So I'm going to put some of these LPs in the description so that you have them at your fingertips. Okay. Now let's see what that does. So I'm going to start an IPR. All right, an IPR started. Now I have LPEs on the right light, the left light, the neon light, and the overhead light. I also have one on the HDR. You can have LPs on the HDR as well. So you can have LPs on any kind of a light. And I'm going to go to the right light. There it is. Now, it's the it viewer, so I can't do any fancy compositing here. But you can see by increasing the exposure, I'm actually increasing the pass. Now, the cool thing is I can have this open while I'm playing with these LPs. Okay. And make changes and refresh the IPR. I would have to stop and start the IPR if I make any changes here. It's not in real time, but you do have to stop and start the IPR. But yeah, you can even see how the overhead light is influencing this back neon light. Now this neon light is a specular material. It's actually glass. I actually made a neon light, a true neon light, which is a glass tube. And then inside the glass tube, I have a mesh light. We'll go over this scene in another episode where I show how I do that and how to create HDAs. We'll also go over the fur. So stay tuned for that. Here's the left light again. All right. And there's the Z depth as well. And this is what they all look like when they're combined. Okay. So you can create LPEs from lights, but you can also create LPEs from objects. So why don't we go over how to do that? So why don't we scroll down? I'm going to turn off these AOVs, and I'm going to turn on these AOVs right here. The Pixar ball and the Psych wall. Now, we haven't gone over that much about shorthand, but all the LPs that you can create, there could be an alternative shorthand version of that LP that uses the wildcard. So you could have, right here we have the wildcard, but that's a functional wildcard. But I could have put a wildcard here, put some 2 dots here, and it would have said anything. I mean, literally any kind of function that happens, any kind of event. I don't care what it is, whether it's reflective, diffuse, transmissive, diffuse, anything, record it. And that's how we're going to do this next AOV, and you'll see it a little bit. So let's go over that. So here's an LP where the camera is going to record anything. That's the wildcard that has Psych wall in its name, and it's going to record all bounces and to all to any light in the scene. So any light in the scene that lights this, record it. And emissive lights as well. Okay? So let's see what that looks like. Here's the Psych wall. So only the Psych wall is getting illuminated and recorded. Only, and that's the passage that we are writing out. Okay. Let me show you how that is done. So if I go to the Psych wall and I go to, you might have to add a spare parameter, which is done right here. Once you highlight an object, a GeoNode, go to click spare parameter. It will create a tab, a RenderMan tab. And this is where you do all your customized settings for RenderMan. And we're going to attributes, and we're going to go to lighting attributes. And there is a identifier LPE group. Again, highlight, it'll tell you what it does. And we named it psych_wall, which is used right here with single quotes. And we did the same thing for Pixar ball. So again, if I do the IPR, I can isolate the ball. So here's just the ball. Here's just the wall. And I could have done one for the sign if I wanted to. And there's interesting effects that you can do in post with this kind of information. Okay. So that is really the crux of this episode. That's pretty much it. LPs are incredibly powerful. They give you immense granularity after a render is finished. Could you use it to do some crazy stuff like I did in my scene? Sure you could. It's designed for tweaking for the most part, but you could. I mean, you can do whatever you want. But I think most people in the professional pipeline setting are using it to tweak a rendering that has already been decided upon in the DCC, and the look dev's already been done in Solaris or Houdini or Blender or Maya or Katana. And then they're just tweaking it. They're massaging the passes. Little things. Like, oh, you know what? We don't need that overhead light to be as powerful. So let's dumb it down. Let's turn off that neon light completely. Let's see what that looks like. That kind of a thing. So I hope you found this episode informative. Any questions you might have, please do not hesitate to put them in the comments section, and have a great week. Thanks for watching, guys.